Okay, so here we are with the final part of 6.2, right? Part 3. Um, and this is where we're going to get into actually combining random variables. So we did all the transforming, right? And the second half, as I said, this is where we are combining random variables. There is a difference. Transforming is you're doing something to each x, in the distribution. Combining random variables, you're actually taking two separate distributions and you're going to be putting them together into one distribution, as a sum or difference of the entire distribution. So to kind of let this all play out, I have two different distributions. I have x, right, which is going to consist of the numbers 1, 2, and 5, and then probabilities would be 0.2, 0.5, zero point 0.3, and I'm going to let distribution y consist of the numbers 2 and 4, and 0.7, zero point 0.3 as probabilities. Okay, so I guess to kind of start us off here, we can find out the values for the means and the standard deviations, right? So we have mean of x, standard deviation of x. So this is 1, 2, and 5, 0.2, 0.5, zero point 0.3, right? And calc 1 var stats 2.7, and this is 1.55. We'll go 1.552. All right, and then the same thing with the y. So mean of y, standard deviation of y, and this, right, quickly just put these in here, and this would be 2 and a 4, calc, and you've got 2.6 and standard deviation of 0.917. Okay, so there's our basic, you know, stats, and from there, what we're going to do is I'm just going to do it for the one with the addition. And we're going to say, okay, let's say we combined x and y. We pick one from x, we pick something from y, and we combine it into a new distribution of the sum of the two. Okay, so for example, I can have, say, a 1 from here, a 2 from here, right, which is a possibility of a sum of 3, right? So that would be actually 0.2, right, because you need the 1 from here and the 2 from y times 0.7, so that's going to give us a 0.14 probability. Okay, then we can have an outcome of a 4. Well, in order to get a 4, you would have to have a 2 from x and a 2 from y. 0.5 times 0.7. You need both of those, so that's 0.35. Then we go up to, we can get a 5, right, which means you're going to have a 1 from x and a 4 from y. So 0.2 times 0.3, that's going to give us 0.06. And then we can also get a 6, which is a 2 from x and a 4 from y. So 0.5 times 0.3 should be 0.15. We can get a 7, which would mean you have the 5 from x, 2 from y, so 0.3 times 0.7, that's 0.21. And the last one would be a 9, meaning a 5 from x, a 4 from y, 0.3 times 0.3, that's 0.09. Okay, so we've created a new distribution of this distribution plus this distribution and all the possibilities that can happen. So if we go into our window, right, so we got 3, 4, 5, 6, 7, and 9, and probability is 0.14, 0.35, 0.06, 0.15, 0.21, 0.09. Okay, so we do our 1 var stats, right, and we get a mean, right, we're going to call this x plus y. The mean of x plus y is 5.3, and we get a standard deviation of x plus y of 1.803. Okay, so what I want you to do is I want you to take a look at these values and then take a look at these values, right? And one of them is actually going to be a lot easier to figure out than the other, right? And the other one's not so much, but if you actually played around with the numbers a little bit, it might be a good time to pause and see if you can kind of figure out what's going on. But the one that does stick out is 2.7 and 2.6. If you added those together, right, you get 5.3. Okay, so the mean of the sums is the same as the sum of the means, right? And we'll define that in a few minutes here. So that one's a lot easier, but if you want to try to mess around with how I get this, it is going to come from those two, right? So it might be a good idea to pause the video at this time and see if you can figure it out. All right, so then if you haven't noticed or figured it out or haven't seen, because if you go 1.552 plus 0.917, you add those together, you get 2.469. That's not the same thing, right? That's because standard deviations do not add, all right? I repeat, standard deviations do not add. So don't add standard deviations. But take a look at this, 1.552 squared plus 0.917 squared, right? If I square the standard deviation, what's that value giving me? That's the variance. That's the variance. You got a variance of x plus y, square root of that, 1.803, 1.803. Okay, so standard deviations do not add, but the variances do add. So this is that time in the beginning of the course when I was saying variances are going to come back. We're going to use them again, and you'll see why. This is that reason why. That's why they're useful to us, because we can add standard deviations. We cannot add we can add variances. My apologies. We can add variances. We cannot add standard deviations. Okay, so I could do the same thing here with x minus y, and what you'll notice is the means, right? You can subtract the means. The variances still add, right? So it's always adding the variances, regardless if you're doing an x plus y or an x minus y. Okay, so just to kind of get us into kind of formally, looking at these, we would have if we were combining random variables, right? So this would be the rules. Rule for combining means. Okay, so the rule for combining means, this would be for any two random variables, right? So any two random variables, we would say that the mu of x plus y is equal to the mu of x plus the mu of y. All right, and if this was the mu of x minus y, again, we would take mu of x minus mu of y, right? So that would be the rules for the means, right? So the mean of the sums is the sum of the means. The mean of the differences is the differences of the means, right? Simple enough. Part B would be the rules for combining variances, right? Again, it's not standard deviations. You're combining variances here. And if you were to do that, this would be for any two independent random variables, right? So there's a little bit of a stipulation here. These must be independent. With the means, notice it didn't have to be independent random variables, it just had to be two random variables. To combine variances, you must have independent random variables. And if you have independent random variables, the variance, right? Notice sigma squared, right? Variance of x plus y is going to be the variance of x plus the variance of y. Okay, which means the standard deviation of x plus y is equal to the square root of the variance of x plus the variance of y. Okay, and if we were to do that for x minus y, the variance there, so you would take x, you still add variances, right? So regardless of this being an addition or subtraction of distributions, right? Not values, but distributions now, you're always going to add variances, right? So the variances always add, okay? So the standard deviation of x minus y, right, would be the same. This would be the variance of x plus the variance of y, and then the square root. Okay, so there's your rules for variances. All right. Again, I'm going to note to never add standard deviations. Okay. Standard deviations do not add. It's the variances that do add. All right. So as far as we're concerned there, that's the combining rules, right? So I do have actually one more part that's going to be a couple examples that we can go through with the combining so you can see how that all works. All right, but that way it'd be kind of its own little part. All right, so stay tuned. We got part 4 coming up, and that would be the final part.